Vedantu daily sessions. Well, we have been talking about the chapter chemical reactions and equations from past videos, and in today's class finally we are going to talk about types of chemical reactions. Even in video number 4, we started discussing about different types of chemical reactions and I gave you various classifications. Reactions based on mechanism, based on energy transfer, and also based on addition of oxygen or maybe reactivity with oxygen, right? And we discussed how to identify combinations and decompositions reactions also in the last video. So today we are majorly going to focus on single displacement and double displacement reactions, which stand as an extremely important category of types of chemical reactions, right? So let's get started without any more delay. In case you have missed all my previous videos and this is the first time you are in my class, you are listening to Dr. Nazma Sheikh, right? So well, we are going to talk about the very first classification that is based on and combination decompositions are done already, so directly jump to single and double displacement reactions. Okay, so what are single displacement reactions and what are double displacement reactions? First, observe the name: single displacement and double displacement. So the reactions are talking about some sort of displacement, isn't it? So what exactly is this displacement? There is another word for the same, which has same meaning, and that is substitute. What's meant by the terms displacement and substitution? I'll give you a simple example. Maybe in the school, when one of your teacher is absent or on leave, another teacher would have substituted the class 5 times, right? Did this ever happen with you? Yes, right? So what is this another teacher doing? That another teacher is trying to substitute the position and the class of the teacher whoever is on leave, correct? Here also same logic applied. Chemistry is very simple. Try to use the simple logics like this. Now, in the chemical equations, if one atom is going and substituting the position of another atom, that's what is called as displacement reaction or substitution reaction. For example, say you have a reaction like this, AB plus C, and now in this reaction C is coming and displacing or substituting the position of A. So what is happening now? A is going on leave out of the molecule and C is coming and substituting the job of A. Then the system will be A plus B, C. Correct? What happened now? B have substituted the position of A. That's it. Nothing else have happened, isn't it? So say A is going out of the molecule and C is coming and substituting the position of A. Then what happens? Of course, C will be occupying the place and it leads to formation of a new molecule called as BC, or you can also write it as CB in the same sequence. So what exactly is happening over here? Is it not a substitution? Of course, this is a substitution reaction, isn't it? But then the substitution reactions that we are talking about is saying single displacement, double displacement and all of that, isn't it? So then what is that? Let us understand that in detail, but before that let us write the product, okay? Place C in place of A. So it becomes C, B and A has come out. Now in simple words, C has substituted A. So this is a substitution reaction, or we also call it as a displacement reaction. But then you tell me something, how many atoms are displacing A? How many atoms here are displacing A? I see only one atom displacing. Do you also see the same? Yes, of course, one atom of C is displacing the position of A. That's why we call it as single displacement reaction or single substitution reaction. So what is single substitution or single displacement reaction? A reaction in which one atom or one species displaces the other. Just like AB plus C leading to formation of Cb plus A. In the same way, I'll give you an actual chemical equations example. You check and see if it is a single displacement reaction or not. Okay, say you have copper sulfate plus Fe leading to formation of FeSO4 plus Cu. Don't worry about the reaction, you will learn it at the end of the class. But now observe what is happening in this reaction. Iron, copper. Iron is coming and occupying the position of copper, substituting copper, leading to formation of FeSO4. Then what is happening to copper? Copper is just going on leave. It's coming out of the molecule. So now you tell me, can we call this reaction, which I have written here, the copper sulfate reaction, can we call this as a single displacement reaction? Of course, we can call it as single displacement. Why? Because one atom is coming and displacing other atom, isn't it? This is what a single displacement, isn't it simple? Yeah, let's take one more example. Okay, this time observe this example. FeSO4 plus Cu leads to formation of, hold on, just think, is it the reverse of the reaction that we have just written here? Yes, it is the reverse of the same reaction. But is this reaction possible? First of all, if one atom has to come and displace the other atom, what are the conditions needed? What conditions? Let me just tell you the principle or the story behind this simple displacement reactions. You know, when so-called atoms are displacing each other, like from copper sulfate, iron is displacing copper. You know, for that iron to come here to fight with copper, to break the bond of copper with copper sulfate and to let it move out and occupy the place to form FeSO4, iron should be very strong. It should be stronger than whom? Than copper. Only when iron is stronger than copper, it goes to copper, fights with it, breaks the bond, lets it out and occupies its own position. So in single displacement reactions, if you want the reaction to happen, if you want an atom to occupy the position of other atom, the one and only primary and important condition is the atom which is coming in should be stronger. Here iron is stronger than copper. That's why this reaction is possible. And now in case I talk about the reversal, FeSO4 plus Cu. Now to be able to displace iron, copper should go to iron, fight with it, break the bond. So copper need to be stronger, but then it is not stronger than iron. Iron is stronger than copper. Iron is stronger than copper. So the reaction between iron sulfate and copper, the displacement of iron by copper does not happen. No reaction. Are you all able to follow what am I saying? I am trying to say that if you want the single displacement reactions to happen, you should be having a more reactive element trying to displace less reactive element. Only then the reactions are feasible. Otherwise, no, they do not happen. But then you might now ask me, ma'am, how do we get to know which is more reactive and which is less reactive? Yeah, this reactivity depends upon a property called as electropositivity and electronegativity. We can compare the values of electropositivity and negativity to understand which is more reactive, which is less reactive. But then at class 10 CBSE, you don't need to worry about all those complications. You just need to learn the reactivity order or the reactivity, maybe increasing order of reactivity or decreasing order of reactivity of some 10 to 15 elements. That will work for now. But later when you actually go to graduation level studies, that's when you will have to compare the electronegativity values and etc. etc. So I give you list directly, you have to learn it. First I'll write the list, but before that, tell me, how many of you remember something by name reactivity series? Remember, I'm talking about the same list then. This list you have studied already in class 8 CBSE in metals and non-metals chapter. It's called as reactivity series, which is nothing but the increasing or decreasing order of reactivity among metals and non-metals, but only metals are in our syllabus of class 10 CBSE. So we don't even study about non-metals now, right? So out of the list, okay, let me give you a disclaimer also. We have so many metals. We have so many metals in the periodic table. The number of metals is above 60. But then you don't need to learn everything. You are going to learn some 10 to 15 metals which are frequently used in your syllabus. So in case you are referring to some other books like S. Chand or Pradeep or maybe Together with Science, and if you get to see some one or two new elements in the list other than what I have written, other than what's there in NCERT, no need to get worried. It's okay. It's okay to have one or two metals added in extra, or maybe to see one or two metals lesser than what you have learned, right? Is that clear? Fine, let's get started with the list. So out of the elements that we study, one of the most reactive element is potassium. Yeah, potassium, followed by sodium, followed by calcium, followed by magnesium, etc., etc. But then learning some set of elements dryly without any logic is a little boring, and it's a little tough as well, isn't it? So just to make it a little interesting and easy to be able to memorize, I'm just giving you one statement which is picked up from the web, from internet, which I found interesting. We call it as a mnemonic, but in case you have a better mnemonic, do let me know in the comment section, because that will help so many students. Yeah. So let me first write the mnemonic or the statement. The statement which I was talking about is, please stop calling me a careless zebra. But before that, let me tell you, the statement is completely senseless. It is only a trick to remember the elements, right? Instead, learn how copper saves gold. You see this? So this is a list of elements that you frequently use. Do you see any elements anywhere? I'll tell you how to decode it. Observe the first letter of every word that's written over here. That's it. That is a hint for you to remember which element comes first and which element comes next in the list. So here the word please, the letter P, reminds you of potassium, sodium, calcium, magnesium, aluminium. Similarly, carbon. Carbon is a non-metal, then why is this carbon in the list? Let me tell you, this is only a reference element. Any element which is present above carbon is considered to be very reactive element. Below carbon, not very reactive. This is a standard, or maybe you can call it as a reference element to understand which elements are reactive and which elements are not very reactive. Okay. Now, following with zebra, zinc, instead, iron, Fe is the symbol. Learn, lead, Pb is the symbol. How, hydrogen. You know hydrogen is an ambiguous element, right? It forms cations, it forms anions. So hydrogen, if it is forming cation, obviously it involves itself in the metal displacement reactions also. That's why we are having hydrogen in the list. Followed by copper. Copper for copper, saves, is silver, symbol is Ag. Do remember, initially STOP, stop, signifies sodium, and at the end saves signifies silver. Don't confuse between both of them. And finally gold. So this is the list of elements which will help you remember the reactivity series. So please stop calling me a careless zebra. Instead, learn how copper saves gold. Learned it? Is it funny? It is, right? That's how things get easier to memorize. But then in case you have better mnemonic, let me know. Let me help many students of mine with your mnemonic, right? So let's come back to the point that we were talking about. We were talking about the single displacement reactions, the most important type of reaction that we are studying. So in single displacement reaction, one atom will be displacing other atom, but then this happens only according to the reactivity series. For example, let us apply our reaction FeSO4 plus zinc. leads to formation of so on so on so products. But then we have to check before writing products if zinc is more reactive than iron or not, because only when zinc is more reactive than iron it can fight with iron and leads to formation of displacement. So you compare and tell me. So zinc is here and where is iron? Iron is here. Oh, zinc is slightly more reactive than iron. Zinc is coming first. Whichever comes first is more reactive. So because zinc is slightly more reactive than iron, do you think this reaction can happen? Yeah, of course it can happen because zinc is slightly more reactive, stronger than iron. So now iron will get displaced by zinc, leads to a formation of zinc sulfate plus iron. Are you all able to follow? You are, right? I'm telling you again, single displacements are super duper important. Yes, I mean it. And moreover, the single displacement reactions are not only part of chapter 1. Going ahead, you have a few more chapters like acids, bases and salts, related to which I'll be making videos soon, followed by metals and non-metals. Chapter number 1, chapter number 2 and chapter number 3. These are the 3 chapters in your syllabus which involve a lot of chemical reactions. And these single displacements are a part of all the 3 chapters. If you're learning them now perfectly, going ahead in chapter number 2 and 3 also, they'll be very helpful to you. Okay, so make sure you learn them without any glitches in between, without any gaps in between. Okay, so now let's try one more reaction, but this time you have to tell me the products. Okay, are you ready? Fine then. So the reaction this time is FeSO4 iron sulfate plus copper. Can you quickly tell me the products? I'm waiting for your answers. If you are assuming that the product is going to be copper sulfate plus iron, your answer is absolutely incorrect. You know why? Before writing the products, you have to check the reactivity. Check the reactivity of copper and iron. Go back to reactivity series. Copper is here and iron is here. Iron is more reactive than copper. Iron is stronger than copper. So can this reaction happen? No, no reaction. You're getting this, right? So only when the incoming element is more reactive, the displacement happens. If it is not more reactive, the displacement doesn't happen. All right. So one final example before moving ahead. Can you check the reactivity for HCl and zinc? And tell me the product. If this reaction is possible, you tell me the product. I'm not going to take you back to reactivity series because I asked you to recall the mnemonic, right? So please stop calling me a careless zebra, zinc. Instead, learn how copper saves gold, hydrogen. So first is zinc and then is hydrogen. So zinc is obviously stronger. Because zinc is stronger, what happens? It goes fights with hydrogen, leads to formation of ZnCl2 plus H2. That's it. Did you see how hydrogen is also taking part in single displacements? Because it forms cations and it forms anions as well. Hydrogen is an ambiguous element. It's dicey. So in class 11 you have a separate chapter about hydrogen. So it is that dicey, right? So guys, this is about single displacement reaction. Let us quickly summarize. In single displacement reaction, one species or one atom will be displacing other. And that one atom could be metal or non-metal. But right now in the syllabus we are going to talk about metals. Okay? And now this displacement happens with respect to something called as reactivity series. And reactivity series is a little tough to remember. So there you go with a mnemonic with the help of which you can remember it easily. Right? So one final time, I'm reminding you how important single displacement reactions are. So make sure you practice them. Once you're done with this, go to NCERT. And in NCERT, whatever examples are given for single displacement reactions, make sure you practice all the examples. Practice examples is not like, okay, whatever is there in the textbook, don't copy it down into the textbook and, into the notebook and write it for some 10-15 times. No. That's not what I meant by practice. Practice is you take the reactants and you write the products without seeing. Seriously, I mean it. And you observe the products and you try to guess what the reactants could be. I'm talking about single displacements, right? So now go to the exercise of NCERT. Maybe I'm sure you have all the reference books with you, right? So go to your reference book, observe a few reactions and try to identify if that particular reaction is combination, decomposition or displacement. combination, decomposition. You remember how to identify them, right? Observe the count of reactants and products, correct? Because identifying the type of chemical reaction is a seriously important type of question. Short question that we get to see almost every year in board examinations. So start practicing from now so that going ahead it gets easy, it gets a little better, because chemistry is not the one and only subject that you are preparing your boards for, right? You have so many other subjects also. You can't spend forever to learn the concepts of chemistry. So learn them now so that later you can spend time for the dangerous SST, history and all of that. Yeah, they need so much of time to study. Right? So guys, I hope this video has been of some help to you. Make sure you subscribe to Vedantu YouTube channel so that you never miss an update about all our videos. And this is the end of chemical reactions and equations. As I mentioned at the beginning, we did not cover everything, but we covered the essence of the chapter. We covered the main essence of the chapter, all important stuff. So now I'll be starting off with second chapter after a few days, acids, bases and salts. But then before that, if you have any particular topic that you want to learn from that chapter, any question, any concept, let me know in the comment section so that I teach you the same. What's the point when you are not getting what you want? But you tell me what you want so that I can give you that, I can teach you that, right? So I'll see you all soon with acid, bases and salts. Until then, bye everyone, take care.